This is lecture 13, example 3. So we've been working with timing. This is kind of an old problem. This is just, a programming problem. So it's a special programming problem. And so what we want to do is write a subroutine that doubles a 2-digit value, BCD value. So the 2-digit BCD value is in x20. We want to double it, place the result in x10. Now, so the issue is to get this right. Now, x10 is the result. Anytime I double two-digit decimal values, I actually could get a third digit, which essentially worst case I add 99 plus 99. The answer is 198. But I need to account for the fact that in some cases I'm going to have 3 digits. So essentially, anytime you're working with BCD, you essentially have to do it an instruction at a time. A digit at a time, and handle the carryouts accordingly. Now, so the issue is that in x20, we'll put it right here. Got the pen. It's x20. The value, it looks like this. This is x20. This is 4 bytes here. This is the ones digit. I'll say BCD, and this is the tens. These are both BCD numbers. They're both 4 bits. Up here, we think these are zeros. We may actually fix that in the program just to ensure. Yeah, we'll fix that when we'll ensure that's right in the program. Okay, so essentially I'm adding these two values. It might have a carryout, which I have to include in the tens, which might have a carryout, which I have to include in the hundreds when I'm done with this thing. But everything is sent as 4-bit, in 4-bit chunks, which is the ones and the tens and the hundreds. So let's go from there. So this problem is going to be typical stuff. I'm not exactly sure how I'm going to do this. Unfortunately, we have to save context, so I'll switch over to the editor in a second here. So let's do this thing. The first thing I have to do is give it a name, 2x BCD, for lack of a better word. Okay, the first thing I need to do is I need to save context. Yep, I always have to do that. Next thing I have to do is init stuff. A couple of things I need to do in here. I feel like I'm going to have to make a working copy of what is sent, and I'm kind of accumulating the result. I have to clear an accumulator in that thing, and so I'm going to I will say massage value. Okay, so that means just mask it. 2x ones digit, and looks good. And then I'm going to say result. I added the ones digit, not the 10. So I'm seeing if the result is greater than 10. If it isn't, I don't really have to do anything. But other than that, this is a yes. If the result is greater, I'm going to have to subtract 10. I'm going to say increment the tens digit. So I'm kind of putting a bunch of information in that one instruction, which is okay. So then I'm going to have to massage the tens. The tens is essentially the tens digits, which means there's a couple ways to do it. Essentially what I'm going to do is clear off the bottom digits and work from 10. Okay, so that means essentially a masking operation. Then I'm going to, you know what? I'm going to add the tens digit, and I'm going to say, let's see, I'm adding the tens digit, so I'll say result greater than 100, and if it's not, oh, you know, I need to do something else too. Not, I am going to, I'm essentially done. Restore the context, and then I'm going to return. Okay, if it is greater than 100, I'm going to increment the hundreds digit, which is essentially the third nibble on this thing. So when I add 10 here, I'm also going to have to add carry. Which is essentially done in that tens operation. It's actually not going to be an operation, but I'm going to pretend it is, and you'll see it in the code how I handle that. And so that's roughly the flowchart in it. Certainly no loops in it, but certainly some if-else statements. So let's crank through this. So I'm going to switch over to the editor and see how fast I can do this. Okay, so this is continuing the problem, and I'm going to work from an editor since it'll be easy. Actually, copied the flowchart down as I went along, and so we're ready to go on this thing. So give this a name. I forgot what I called it. 2x ECD, and I'm going to save context. I'll just say save. Worry about that later, and then I'm going to initialize some stuff. Okay, so the stuff I'm going to initialize will be, let's see, x. The result is returned in x10, and so I'm going to clear x10. So let's move, I'll get it here, x10, x0. That looks good. Typically speaking, I need a working copy of this, of the value that's sent. It's sent in x20. So we'll just say x21. So I'm copying x20 value. Okay, and this is going to be accumulator is where the result's going to be. Okay, so that's takes care of that box, and I'm ready to do my work on this thing. I'll say, I don't know, for lack of a better word, start. Okay, I'm saving extra space here. Okay, so this is going to be, what I need to do is make sure I'm only adding the least significant nibble on this thing, or the lower 4 bits, and so I certainly don't know what was delivered in the upper 6 nibbles, but I need to clear off the upper 7 nibbles. So this is going to be and immediate x20. We'll do x20 0xf. Okay, so that means mask 1's nibble. Okay, so x20 now has just a 4-bit value, and I need to add that add x20. That's going to take what's in x20, add it to x20, and store the result in x20. So that's my double the x20, 2x, x20. Okay, so looking good. And then at that point, I have a value x20. I have to see if it's greater than 10. So I'm gonna use a special instruction that I don't use too much. It's set if less than immediate x20, and I don't think that's it. So we'll say x5. That's register going to be set, and the two registers it's going to compare is x20 and 0x a. We'll say a. Okay, a is 10, and this is a compare with 10. So if it's less than 10, that means x5 gets set. Okay, less than 10, and that's okay. And so what we don't want is when not equal, and this is x5, x0. Okay, if it's not equal, that's the good part. Then I'm going to do tens. Okay, looking good. And so I'll come down here and put a do tens on this. Do tens. All right. Okay, worry about that in a second. So we'll go through this again. If x20, which is adding the two lower nibbles, is less than x10, less than 10, that is good. Okay, and so I can go, if it's less than, it gets set. And let's see if that's right. It's either one way or the other. If it's less than, it gets set, and if it's set, that's what we want. If it's not equal to 0, that's when we have to actually fix it. And so our fix is going to be to subtract 10 from it, x20. Add x20. And we're going to do x20 and minus 10. Okay, so there's our add immediate, subtracting 10 from it, and we have to keep track of that. So I'm going to move a value, load immediate, somewhere. We'll just call it x15, which is the value of 1. So this x15 is what I'm going to have to add into a register. And other than that, I think what we're going to do is initialize that value to 0. So what I'm adding here is either going to be 0 or 1 the whole time. Since if it has a carry, it's going to add 0. So this is my carry register. Okay, and that's it. So what we've done here is we subtracted 10. And we remembered that we incremented this x15, which we're going to add to the tens value. Okay, so here we are at the tens. We already lost our data. We need to work with x21. And so I'm going to say and immediate x21, 0x0f0. Okay, so that's essentially going to work with the tens nibble. Mass, we'll put that in there, mass 10 nibble. Okay, and we'll put a comma in there. Branch if okay. Adjust. And increment carry. Okay, and then we're done with that. Okay, so at this point we have just the tens data, and so we can add that. We're adding in place. We're trying not to shift over on this thing. I know there's a different solution in the other solutions, but I kind of like this solution better. So we're adding immediate, not immediate, x21, x21, so that's doubling the value. So this is 2x the tens value, and looking good. Okay, so at that point we need to do something else. We need to add x21, and we need to add the x15, which is our carry value, and it's x15, and this is add carry. So we don't really know if there was a carry or not, but if there was a carry, I mean, we're just adding it anyway. So if there was no carry, I'm adding 0. And so that's looking good. And I'm going to say, I have to look at this thing, see if this is greater than a certain value. So I'm going to say SLT set if less than we'll put a value in there. So it's x, we'll do x5 again. Doesn't really matter. X, we can reuse x5. And if what we're worried about is x21, if x21 is less than 0x100. Okay, so that's this 1 here is the hundreds digit. So if adding the two tens digit caused the carry, I am now in hundreds digit land, which I have to essentially adjust this thing a little bit. Okay, so this is going to be, what am I going to do here? This is going to be check did set if okay, so this is, I'm going to set if it's less than 100. We'll make it hex, even though they're kind of almost the same in this case. And this is going to be set. Okay, it's set if it's less than 100, so that branch not equal x5. Just copy the other code above, x0 to, sounds like we're almost done on this thing. Branch if no fix. Okay, and this part, make that go away. Okay, so this one we'll call it fix tens. Okay, so fixing the tens means I have to do a subtraction, which I'm gonna add it. So add my answer's in x21, which I know is too big. x21. What I'm gonna add to this thing is x21. It has the whole value, and it's going to it had a carry out, so I need to fix that. And so the number I'm going to subtract from this thing is minus 10, but the 10 is shifted over, so it's actually minus 0x-a0. Okay, so I'm not sure what a0 is. Well, it's 160, but I guess I could do that. But it's 10, and it's in the other location. It's 10 in the tens bit location, so that's what I need to represent, and that should be happy there. Essentially, this should be add immediate, and that should be okay. All right, then I subtracted that. Okay, so I'm subtracting that, and then I need to add another add immediate x21. I have to add the 1 into it, which is the 1 in the hundreds place. 0x, 0. There's the 1 in the hundreds place. And then I think I need to add in our previous result. Add, this is x, we'll just add x10 because that's where we need to put it. x10, x21, x15 has, x15? No, x20 has the previous result. And somewhere we added x15 in this. And I think we're done on this thing, and we can say return. Okay, so I'm going to, I think it's done, and so I'll just say adjust add the hundreds, and then final accumulate, and we're ready to test it. So what I'm going to do here is I'm not going to test it thoroughly, but x, sticking the value x20 gets about 99. 0x99. It's a hex 99. Okay, and let's test this out. 99 times 2 is 198. That's what I should be getting in x10 when I'm done with this thing. Step. Okay, so there's just do the tens. Okay, so there's tens. I'm adding x21 should have 1, oops, X. All right, that's right. And I'm going to set X5, which is blah, 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 X5. Needs to be fixed. So I'm subtracting 160 from X21. Okay. I'm adding in, increasing, I'm adding X20. Okay, this looks good, 190. Okay, then I'm adding in X20, which was the previous result, which should be 9. Which should be 8, 198, so X20. Okay, I stepped on X20. 8, add X20, X10. Why does X10 suck? Here's 198. Oh, it does work. Okay. I don't know what, I was looking at the wrong register before. So this, we're going to call this done. Step through it, everything's fine. I think I made a fix during the break that you should be aware of, and essentially I fixed this thing. I was adding 1 to it, so you can check the other of the old solutions before that. Okay, so remember, this is just the same algorithm twice, and I'm going to call this one done. More complicated than I thought, but certainly it worked out in the end. And even, you know, when I tested it wrong. It was obviously working the first time. So anyway, we'll call it done. So actually, I did take a look at this after I ran another test value through it. Anyway, the issue is the problem is this straighten right here needs to not be part of that loop there. That's the final thing I need to do. So it doesn't matter what I'm doing here. I always have to accumulate those 3 values at the end, and so this makes the overall subroutine right. And so we'll call this done. Should probably test another value, but I did offline and it looks good. So the moral of the story is there are many ways to do this. This is my chunky way. I know there's a double dabble algorithm out there. Get a double dabble. You can go look at that if you're hurting for time or anything. But anyway, that's called done.